Welcome to Module 5.2. This is called Going Green and Life Cycle Analysis. So I'll be covering two distinct topics. The first is going green. And what in the world is green all about? Well, it's very confusing and it is not regulated at all. So whoever's using the word green essentially defines it for themselves. But in general, green generally refers to energy usage. When you go to a store and you see something called a green product, very often it's low energy compared to its usual product. The compact fluorescent bulb is a good example of that. Also, LEDs are very low energy. Refrigerators, low energy. So you can call some of these products green. But usually it's in reference to an existing product. But what about another type of green, like products? Well, there are many environmentally green cleaning agents. And the difference here is that what's good for the environment may not necessarily be energy efficient. So environmentally green and energy green are two very different concepts. And finally, a new movement is essentially for worker health. Is it good for workers? While they're making the products, is there less occupational disease from it? So the question for you is, can you possibly have a product that's energy efficient and good for the environment and healthy for workers? Well, I seriously doubt that. You could probably have two of these items, but all three would be a long shot. So the word green is extremely problematic, especially when it comes to something like compact fluorescent light bulbs, which contain mercury, weigh 10 times as much as the other light bulb equivalent, is very complicated, has a circuit board in it, and is very costly. So there's nothing environmentally green about this product or safe for workers. But it does use low energy. The next topic is called life cycle assessment or analysis. The point of this one is essentially comparing products and saying which one is better overall for both energy and environment. You've probably struggled with the whole idea of which is better for the environment, an old-fashioned incandescent light bulb or a modern light bulb. And when you compare energy, it may be a slam dunk. But when you compare environmental consequences, including disposal, it's far from it. Same thing goes for paper bags versus plastic bags. I'm sure you've all struggled with this. Aluminum bats versus a wooden bat. Disposable diapers versus reusable, washable diapers. All these would consist of a life cycle analysis to quantify the hazards. Even the blackboard versus the common markers we have today. These are two products that have sort of battled it out. However, what's not considered in life cycle analysis are the health costs. So the reason we don't see blackboards anymore is because there's so much occupational disease from teachers who've used chalkboards all their life that they've slowly been phased out. Essentially, the dust from that chalk is causing disease, which is not caught in a life cycle analysis. So what are the types of life cycle analyses? Well, let's go from the narrow to the very broad. And the narrow would be energy or petroleum usage. Exactly how much oil does it take to make a calculator, to make a pen, to make a piece of paper? Very narrow assessment. But the more narrow, sort of the more easily quantified. The next one would be a cradle to grave, from the birth of the material to where it's delivered to the manufacturer who's going to use it. Think of aluminum. What does it cost to extract aluminum ore, ship it to a factory, process and get aluminum ingots, and then bring them to the gate so we can make cans of soda with it? That would be cradle to gate. This is the most consistent, most common, and it's called the Environmental Product Declaration, the EPD. A more complicated one would be cradle to grave, from the birth of a material to the death of a product. Using our same example, it would be mining the aluminum, making the can, making the soda, getting rid of the soda can. That would be cradle to grave. Again, more complicated. And the ultimate, but the absolute most complicated to quantify would be cradle to cradle, which would be getting the aluminum out of the ground, making the can, making the aluminum, making the can, making the soda, using the soda, and then recycling that aluminum. Clearly, a cradle to cradle would be most efficient, but again, very difficult to quantify. That's why we essentially go with cradle to gate. But despite this, you still don't see products with an environmental declaration on it. Only in something like refrigerators you'll see an energy rating, but rarely will you see an environmental index on this. So it's still a developing field. Let's look at the life cycle analysis of blackboard chalk. First of all, we have to mine the gypsum out of the ground. Then we have to ship it to a factory and process it and make the chalk itself. Or at least make the gypsum, extract the gypsum from the ore. We have to then ship that to a factory, which makes it into chalk. The chalk then goes to a user who uses it, and then of course wipes the board and throws it out. For each one of these processes, the question is how much energy is used, what is the tire wear, the road wear, the insurance costs, the greenhouse gases, the particulate pollution, all of the costs associated with each one of these steps. And you compare a life cycle analysis. You could sort of mentally do this qualitatively with disposable diapers. And then you'll see disposable diapers versus washable diapers. Which one wins out? I'll let you think about that. Okay, that's it with Module 5.2, Going Green and Life Cycle Analysis. Again, I want you to think twice. Think of me when you look at the word green in a store and ask exactly what are they talking about. Good luck.